Hi, welcome to our course on Big Data from Eduonix. I am Murali and I will be your instructor for this course. In this course, you are going to learn about Introduction to Hadoop. Before getting into the Hadoop concepts, let us get to know the background of it. How many of you know distributed processing? We will try to understand this with an example. In this slide, we are looking at a set of logs and an elephant to carry the logs. Let's assume one elephant can move one set of logs in 15 minutes. Now, if we keep adding more set of logs for the same elephant to move, the time taken will be high. It can take up to 1.5 hours or even more. This is because the same elephant is loaded or even overloaded continuously. If we now keep adding more elephants on the right hand side to move the other set of logs, the average time taken could be around 15 minutes, as the load is distributed among more elephants equally and it is processed parallelly. So from this slide, we have understood that load can be distributed by adding more resources to do the same work. Let's now understand distributed processing in the computing world. In this slide, we have one dataset to be processed by a single processor. If we keep adding more datasets to the processed by a single processor, the processing time will be naturally high. But if we increase the capacity of the processor by 4 times, like a quad-core processor, the processing time would be less but not consistently linear. This is because adding more capacity to the processing would increase the efficiency, but not the expected consistency. This kind of distribution is called vertical distribution or scalability of load, where resources are added to the same machine to process. Usually this will not last longer because as the amount of load keeps increasing, we cannot keep adding more and more processing capacity to the same machine, and there will be a limit to adding more processing capacity, and hence it reaches a saturation. It cannot handle load anymore, and it would eventually die down. Scaling vertically, which is also called scaling up, usually requires downtime while new resources are being added, and it has limits that are defined by the hardware, as scaling is done through a multi-core. Even these machines come at huge costs on top of they being the single point of failures. When Amazon relational database customers need to scale vertically, for example, they can switch from a smaller to a bigger machine. But Amazon's largest RDS instance has only 68 gigs of memory. Few pros of scaling up are it consumes less power as compared to running multiple servers, and of course the administrative efforts will be reduced as you need to handle and manage just one system. But on the consequences side, there is a greater risk of hardware failure, which can cause bigger outages and limited scope of upgradability in the future. And of course, the overall cost of implementing is really expensive. I hope you understood this slide. Looking at the limitations of vertical scalability, let us also try to understand the dynamics of horizontal scalability. In this slide, we notice that we have more hardware to process the same amount of data. With horizontal scaling, it is often easier to scale dynamically by adding more machines into the existing pool, so that they work as a single logical unit. An important advantage of horizontal scalability is it can on the fly we can add more and more machines. Another advantage is that in theory, horizontal scalability is only limited by how many entities can be connected successfully. The distributed storage system Cassandra, for example, runs on top of hundreds of commodity nodes spread across different data centers. Because the commodity hardware is scaled out horizontally, Cassandra is fault tolerant and does not have a single point of failure. Horizontal scaling, also referred to as scale out, is basically the addition of more machines or setting up a cluster or a distributed environment for your software system. Couchbase, a NoSQL database as well, it can partition the data automatically across the cluster. Adding nodes is very simple, and you can use commodity hardware, which is on the cheaper VM instances. Pros of scaling out are it is cheaper compared to scaling up, and we can take the advantage of smaller systems. It is easy to upgrade and resilience is improved due to the presence of discrete multiple systems. I assume you have now understood the differences between vertical and horizontal scalability, which is the base of our big data course. Let's now talk about Hadoop, which is this distributed processing system. As per wiki definition, Hadoop is an open source software framework for the distributed storage and distributed processing of very large datasets on the computer clusters built from the commodity hardware. The genesis of Hadoop came from the Google's file system paper that was published in October 2003. In 2006, a development was started on the Apache Nuts project but was moved to the new Hadoop. Below I have mentioned few internet leaders like Facebook, Yahoo, Amazon and eBay who have adapted Hadoop as their big data processing solution. The scale and variety of the data being generated now challenges the relational databases, and that is where Hadoop can really add benefit. Hadoop development is hosted by the Apache open source community, and all major technology companies have contributed to the code base enabling the Hadoop. In addition, Hadoop is self-managing and it can easily handle hardware failures as well as scaling up or down its deployment without any change to its code base. Hadoop installs on low-cost commodity servers, reducing the deployment costs. Hadoop is now widely used across many sectors, including entertainment, healthcare, government, and market research. Let's look at Hadoop's implementation at Facebook. Facebook is one of Hadoop's and big data's biggest champions, and it claims to operate the largest single Hadoop distributed file system cluster anywhere, with more than 1,000 petabytes of disk space in a single system as of this is July 2012. Facebook runs the world's largest Hadoop cluster. With trillions of users and billions of page views every day, Facebook ends up accumulating massive amounts of data. One of the challenges that they have faced since the early days is developing a scalable way of storing and processing all the data, since using this historical data is a very big part of how it can improve the user experience on the Facebook. As Hadoop provides a framework for large-scale parallel processing using a distributed file system and the MapReduce programming paradigm, developers latched onto the MapReduce programming model and started doing interesting projects which were previously impossible due to their massive computational requirements. Facebook has multiple Hadoop clusters deployed now all over the world. In this presentation, we understood the concepts of Hadoop and its implementation and growth at Facebook. Let's see if we understood well from the quiz in the next slide. What is distributed processing? What is Hadoop? And how is Hadoop cost effective and how it is playing a bigger role in the major internet companies? This is the end of the presentation. I hope you like the presentation and keep watching more related videos from Eduonix. Thank you. Hi, welcome to our course on Big Data from Eduonix. I am Murali and I will be your instructor for this course. In this course, you are going to learn the ecosystem, components, and features of Hadoop. Let's talk about Hadoop ecosystem. The Hadoop ecosystem includes both official Apache open source projects and a wide range of commercial tools and solutions. Some of the best known open source examples include Spark, Hive, Pig, Oozie, and Scoop. Most of the solutions available in the Hadoop ecosystem are intended to be supplementing one or two of Hadoop's 4 core elements, which are HDFS, MapReduce, Yarn, and common libraries. The ecosystem table is broadly divided into 5 sections as you see here. We will go over all these broadly later as we have sessions to cover them in detail. Let's look at integration and governance section. Apache Falcon is a data management framework for simplifying data lifecycle management and processing pipelines on Apache Hadoop. It enables users to configure, manage, and orchestrate data motion, pipeline processing, disaster recovery, and data retention workflows. Coming to the real-time data ingestion, Flume is a distributed, reliable, and available service for efficiently collecting, aggregating, and moving large amounts of log data. It has a simple and flexible architecture based on streaming data flows. Storm is also a complex event processor and distributed computation framework written predominantly in a Clojure programming language. It is a distributed, real-time computation system for processing fast, large streams of data. Coming to the batch processing, Scoop is a system for bulk data transfer between HDFS and structured data stores as RDBMS. Let's look at the data access section. MapReduce is a programming model for processing large datasets with a parallel distributed algorithm on a cluster. Apache MapReduce was derived from Google's MapReduce. It is the core of Hadoop. Apache Pig provides an engine for executing data flows in parallel on Hadoop. It includes a language, Pig Latin, which is for expressing these data flows. Apache Hive is developed at Facebook. It is a summarization, query, and analysis tool, works on the top of Hadoop data. Coming to Spark, which is a framework for writing fast, distributed programs within memory. Spark solves similar problems as Hadoop MapReduce, but it does it with a fast in-memory approach. In the data management, we have Yarn and HDFS, which are the other core components of Hadoop. Yarn is a framework that facilitates the distributed processing frameworks and the applications. It is a resource management platform. The Hadoop Distributed File System HDFS offers a way to store large files across multiple machines. Hadoop and HDFS were derived from Google File System paper. In the operations section, we are looking at Apache Ambari, which is the Hadoop Management Web UI, which was donated by Hortonworks to Apache Foundation. It's a powerful and nice interface for Hadoop and other typical applications from the Hadoop ecosystem. On the security part, the Knox gateway runs as a server that serves one or more Hadoop clusters. This covers not the entire, but the most important and the best projects of Hadoop ecosystem. Let's now look at the core components of Hadoop. We should understand that Apache Hadoop Software Library is a framework that allows for the distributed processing of large data sets across clusters of computers using simple programming models. It is designed to scale up from single servers to thousands of machines, each offering local computation and storage. The 4 main components include Hadoop Distributed File System, Hadoop Yarn, Hadoop MapReduce, and other common utilities. In brief, a distributed file system, also known as HDFS, provides high throughput access to application data. It provides reliable data storage and access across all the nodes in a Hadoop cluster. It links together the file systems on many local nodes to create a single file system. Hadoop Yarn, which is a framework for job scheduling and a cluster resource management. It stands for Yet Another Resource Negotiator. Hadoop MapReduce, which is a yarn-based system for parallel processing of large datasets. The important innovation of MapReduce, it is the ability to take a query over a dataset, divide it, and run it in parallel over multiple data nodes. Distributing the computation solves the issue of data too large to fit into one single machine. And with commodity Linux servers, we have a cost-effective alternative. HDFS and MapReduce are very robust. Servers in a Hadoop cluster can fail and not abort the computation process. HDFS ensures data is replicated with redundancy across the cluster. And at its heart, Hadoop is a batch-oriented system. Data is loaded into HDFS, processed, and then retrieved later. There are many other related projects like Hive, Pig, Zookeeper, Spark, Ambari, which we discussed in our earlier slide. I hope it is clear from this slide. Let's look at the features of it closely. Hadoop has the ability to store and analyze data present in different machines at different locations. It can handle large volumes of structured and unstructured data more efficiently than the traditional enterprise data warehouse. Hadoop is open source and therefore it can run on commodity hardware. That means the initial cost savings are dramatic with Hadoop. In Hadoop, the data is stored in HDFS where data automatically gets replicated at 2 other locations depending on the configuration. So even if 1 or 2 of the systems collapse, the file is still available on the 3rd system at least. A high level of fault tolerance. Hadoop is an extremely scalable platform where new nodes can be easily added into the system as and when the data volume of processing needs to grow without altering anything in the existing systems or programs. Hadoop is written in Java and is supported on all major platforms. Hadoop supports shell-like commands to interact with HDFS directly. Hadoop is extremely good at high-volume batch processing because of its ability to do parallel processing. Hadoop can perform batch processes 10 times faster than on a single thread server or on the mainframe. Let us now look at the benefits of it. These are the key benefits which I thought would be really important for us to know. Hadoop brings the ability to cheaply process large amounts of data regardless of its structure. Looking at the scalability and performance, we see that distributed processing of data local to each node in a cluster enables Hadoop to store, manage, process, and analyze the data at petabyte scale. And coming to reliability, large computing clusters are prone to failures of individual nodes in the cluster. Hadoop is fundamentally resilient. When a node fails processing, it is redirected to the remaining nodes in the cluster and data is automatically replicated in the preparation of the future node failures. And flexibility and low cost are also one of the main features of it. Unlike the proprietary software, Hadoop is open source and runs on the low-cost commodity hardware. You can store data in any format, including semi-structured or unstructured formats, and then parse and apply schema to the data when it is read. In this presentation, we understood the components, features, and benefits of Hadoop. Let us see if we understood well from the quiz in the next slide. What is Hadoop ecosystem? What are the main core components of Hadoop? And what are the main features of Hadoop? If you are able to answer these questions, I am pretty sure that you understood the presentation. This is the end of the presentation. I hope you like it and keep watching more related videos from Eduonix. Thank you. Hi, welcome to our course on Big Data from Eduonix. I am Murali and I will be your instructor for this course. In this course, you are going to learn few use cases of Hadoop in different industries. Let's talk about few happenings at Nokia. Nokia has been in business for more than 150 years, starting with the production of paper in the 1800s. With their 2007 acquisition of Geospatial Information Systems, a pioneer, Navtech, Nokia found itself sitting on a mountain of valuable information, and it set out on a mission to help people navigate the physical world using digital data. To do this, Nokia needed a technology infrastructure that would support the collection, storage, and analysis of virtually unlimited data types and volumes. This is what led Nokia to Apache Hadoop and cloud era. Nokia's big data ecosystem consists of centralized petabyte-scale Hadoop cluster that is interconnected with a 100 terabyte enterprise data warehouse and numerous Oracle and MySQL data marts and visualization technologies that allow Nokia's 60,000 plus users around the world to tap into the massive data store. Multi-structured data is constantly being streamed into Hadoop from the relational systems, and hundreds of thousands of scribe processes run every day to move data from, for example, servers in Singapore to a Hadoop cluster in the UK. Nokia is also a big user of Apache Scoop and Apache HBase. This ecosystem is helping Nokia achieve its goals by ingesting terabytes of data from phones in use, services, log files, and other sources, and thus processing the data for market insights and other analytics. Specifically, Nokia is using the data to help people navigate the physical world by building 3D digital maps that incorporate traffic models that understand speed categories, recent speeds on the roads, historical traffic patterns, elevation, ongoing events, video streams of the world, and many more. Navtech has had quite an interesting career. It was sold to Nokia initially, then renamed to HERE, which was then bought by Audi, Mercedes, and BMW. Let's try to understand the oil sector. The oil and gas industries are facing major challenges. The costs of extraction are rising, and the turbulent state of international politics adds to the difficulties of exploration and drilling for new reserves. In the face of big problems, its key players are turning to big data in the hope of finding solutions to these many pressing issues. Chevron hopes to reduce the cost of sending deep water drill ships out into the ocean by doing a better job of processing the vast amounts of data that can help identify reservoirs of oil, which is using Hadoop. Royal Dutch Shell is one of the largest oil and gas companies, and it is also one of the super majors, which also include British Petroleum, Chevron, Total, and ExxonMobil. Shell uses fiber optic cables created in a special partnership with Hewlett-Packard for these sensors, and the data is transferred to its private servers maintained by Amazon Web Services. Shell also uses big data to ensure its machines are working properly and spending as little time as possible offline due to the breakdowns and failure. Machinery used in drilling has to operate in harsh conditions for prolonged periods of time and so is prone to wear and damage. To counteract this, the machinery is fitted with sensors collecting data about its performance and comparing it with aggregated data, which means parts can be replaced in an efficient manner and downtime is minimized. And finally, it further reduces the overheads. As well as exploration, big data is being put to use to streamline the transport, refinement, and distribution of oil and gas. According to Cisco's 2015 report, in New Reality for Oil and Gas, a typical offshore oil platform generates as much as 2 terabytes of data each day. Only a snippet of that data relating to the detection and control of out of normal conditions are actually being used. Let's look at the airport information. Schiphol Group, the company that operates Dutch airports serving over 55 million passengers a year, consolidated all its data in a scalable big data infrastructure using the latest technologies to ensure privacy and security. All data from Schiphol Group are consolidated in this first cloud-era big data solution on Microsoft's cloud hosting platform, which is Azure in Europe. The implementation of Data Science Suite, Schiphol Group and GoData Driven started to work together on the development of data science solutions to improve the operational efficiency. In this presentation, we understood about various big data implementations in oil, airports, and telecom industries. Let us see if we understood well from the quiz in the next slide. What are the main sources of big data in telecom and navigation domain? How is oil industry contributing to big data? This is the end of the presentation. I hope you liked the presentation. And please keep watching more related videos from Eduonix. Thank you. Hi, welcome to our course on Big Data from Eduonix. I am Murali and I will be your instructor for this course. In this course, you are going to learn about installation and configuration of Hadoop single node cluster on Amazon EC2 instance. In this slide, we are looking at all the steps which are involved in the installation. We download Apache Hadoop 2.7.2, which is the stable version. We create all the required directories and we install finally the Hadoop. Later on, we create few symbolic links that is also part of the configuration. We format the nodes and finally look for starting and shutdowning the servers. As part of our first step, we will be now downloading the 2.7.2. If you can go from your browser to this particular location, in the archives of Apache, we see all the releases and we need to go to 2.7.2 and from there you can look out for 2.7.2 tar gzip file, which is around 200 megabytes. We need to download that file. I have already downloaded it on my machine, so we are going to use that. This is our downloaded file, so we are going to copy it to the Amazon. Before copying, let's open a session so that we can copy the file. If you log into Amazon AWS console, we are seeing, and let's go to all the running instances. And here we have our instance. So let's start this instance. And we have this IP here. So let's copy this IP from here. This is mobile xterm. Here we can open a session to connect to Amazon with an SSH. We are specifying the username as Ubuntu. We need to provide the key as well. Let's provide the key. Before starting it, let's see if Amazon instance is already started. Okay, it is now running. We can see that here. So let's go back to our session and click on OK. Okay, we have now logged in. Let's see what is there, which directory we are. We are at home Ubuntu. Let's go to cd/opt. What do we have already? From our previous session, we have already installed JDK. Let's now open one more session, a Windows session, to copy our downloaded Hadoop installer. In session, go to SFTP, provide all the provide the username as Ubuntu, and we need to again copy the file. We need to mention the private key. Okay, we have now logged in. So that's the default home Ubuntu. We can copy the file. We are now copying the file. Okay, while the copying is going on, let's try to create few directories required. Okay, let's now change the ownership of opt. Sudo ch own user Ubuntu, and in the recursive mode. Okay, and let's create two directories within opt. We are there now, and there is Java there. Make dir Apache and make dir data. And within data, let's create two more directories. Let's go to data. One for Hadoop and one for Yarn. File is now also copied. Let's also see. So why did we create the data directory here? Because we are going to configure all our log files or all the server related files, the startup logs, everything is going to be put in the data part. And all the installations of Hadoop or whatever other installations we are going to do it, we will be doing it in the Apache directory, and all the data related things on the data directory. So we have at the root level, we have at the OPT, we are at the OPT, and at the OPT level we have two directories, one for Apache and one for data. In the Apache we have all the installations, and in the data we have all the log files or server files and so on. Let's see where we have our installed downloaded file, cd, and here is our file. Let's copy it to the Apache folder. Okay, and what else we did? We have our file here. Let's extract that. What do we have now? So we have the tar file. Let's also extract the tar file. Good. And now we have Hadoop, and we can delete the tar file. Alright, so we have Hadoop directory now. Okay, so what have we done now? We have downloaded Hadoop and created all the required directories and also installed. Now let's do the configuration. As part of configuration, we will be creating all the symbolic links, and we format the nodes. Yeah, so let's go back. Let's create a symbolic link for Hadoop. Why do we need to create a symbolic link? Because Later on, if we are going to upgrade our Hadoop version from 2.7.2 to any higher versions or lower versions, we can easily point it. So how does our symbolic link looks like? It would be just like OPT, Apache and Hadoop. So this is how it looks like. So let's create that with the ln command -s opt /Apache/Hadoop. So this is our source and we link it to So with this way we can always directly come to Hadoop and it would internally point to 2.7.2. Later on, if someone is upgrading to 2.7.3, we just have to upgrade our symbolic link. So we can test this link by changing the directory. You can notice it here. We can directly come to Hadoop and it is now pointing to the Hadoop 2.7.2 version. Yeah, clear? All the configurations which we need to put it in the dot profile or in the bash file, so that when we log in and we start or stop the servers, it will automatically pick up all the required configurations. So let's copy them, and I'm putting the Hadoop home directory, which is opt Apache in the had home, and for the actual Hadoop itself, the Hadoop home is within that had home. I have put Hadoop there. And we also need to configure the yarn home and MapReduce directories as well. And finally, we put also Java home directories, which is also required for Hadoop. I have also mentioned a couple of new aliases, which is Hadoop and logs. So we can just use them. They are quick shortcuts. Let's copy all this configuration. Let's we can from the home directory vi dot in the dot profile we can set everything. I have copied everything, so let's save that as well. Let's see if this now works. We can open one more session and see if that is really working. Type Hadoop and see if that is. So that is already working now. Let's look at closely what are the configurations which we have done. So this is the Hadoop home directory, which is in the part of which is within the Apache directory, and the configuration directory is within Hadoop. We have etc, and under that we have Hadoop, and the MapReduce home directory is of course the main directory itself, that is Hadoop, and also the common libraries are also within Hadoop, and HDFS home is also, we mention it as Hadoop, and yarn also. And for the log directories, here we are mentioning opt data Hadoop and the process ID. So Hadoop, when it starts, it creates a process ID, and that process ID we will be using the directory of Hadoop itself. And also for the logs of yarn, we are using data yarn, and also the PID directory for yarn as well, the same directory. And the PID directory for MapReduce, we use Hadoop PID, and also the logs for MapReduce is Hadoop MapRed. I hope it is clear so far. Now create the three main directories within the data directory. So within Hadoop, we create an HDFS directory, and within HDFS, we create one for name node and one for data node, so that all the logs related to those particular nodes will be written there. So let's do that. We are at the data directory now. Let's go to Hadoop. And we don't see anything now. Let's create HDFS. Let's create two more. One for name node and one for data node. So we have these two directories here. Okay, now that we have these two directories, so when we start the server and we keep running it, all the logs information related to name node and data node would be stored here. Let's look at the configuration part. Let's go to Apache. In the etc directory, you see Hadoop. Here we are seeing all the configuration files which we have to configure. So one is the core site file, and we have an HDFS site file, and we have also, of course, also the MapReduce and yarn site files. So these are the four main files which we have to configure. And also we have certain log files, log4j properties and other files. So these are the main configurations which we have to update. We will be doing all these configurations in our next session. So we continue with the Hadoop configuration in our next session. And I hope you like the presentation and keep watching more related videos from Eduonix. Thank you. Hi, welcome to our course on Big Data from Eduonix. I am Murali and I will be your instructor for this course. In this course, you are going to learn about few configuration files which have to be updated for Hadoop's installation. You know that we have already updated few configurations in our previous sessions. Let's look at the remaining configurations. These are the few files which we have to update. Let's look at the core site XML. This is one of the most important files of Hadoop's configuration. This contains one of the key parameter, which is the default name of the file system. The HDFS site XML, this contains the data replication factors, which we have mentioned it as 1, and also the name node and data node paths. You are seeing here the name nodes directory path, and also the data nodes directory path, and also the web UI addresses for both name node, data node, and also the secondary data node. This is the configuration for yarn site XML file. This contains the main configurations for the web applications of resource manager, also the zookeeper's address, and also certain more configurations. We have the Hadoop's environment shell script. We will be configuring the Hadoop's home directory and also more parameters, and we would be exporting them. We would be also mentioning the home directory of Java. In the MapReduce site XML, we will be mentioning what is the framework which we have to apply, and here we are mentioning yarn, and the other possible attribute value is local. We have a couple of more shell scripts which have to be updated. Here we would be mentioning the Hadoop's MapReduce, the process ID directory, and also the log directory. We need to perform similar configuration for yarn as well. And in the Hadoop daemon shell script, we have to update the Hadoop's home directory, the configuration directories, and so on. Let us now update the actual configurations itself. Okay, type Hadoop. In the etc, we have Hadoop directory. Let's do it step by step. We will open the core site file. I have already updated the configuration here, so you can notice that it's an empty file with just the empty configuration attribute. I have copied the configuration from theirs, and here you are noticing the actual DNS name from our Amazon server. I have also put the configuration into the HDFS file as well. So make sure you are updating the proper DNS name from our Amazon website to here. Let's look at the yarn file. I've also mentioned, I've also updated all the configurations, so you can make sure all these configurations are up to date. Let's open the MapRead file. Originally, there wouldn't be any MapReduce site file. We have to copy it from the template. So make a copy of the template of the MapReduce site XML file from here, and make a copy of it, and then you can update the configuration. Here we are only updating the framework. Let's look at the shell script of the environment. Here we have already updated the PID and the log directories here. I have mentioned all these parameters, and we are exporting them. I have also put all the configurations in the Hadoop shell script environment file. The only one file which is left is in Edspin. We have daemon file. I have also mentioned all the configuration which is required, all the parameters which would be exported. Yeah, I hope it is clear so far. Make sure you also copy your private key to the server itself. So in the home directory, if you go to cd.ssh, I have copied your private key from your local machine using SFTP, Windows SFTP. I have copied it here, and this is first thing. And next, what you can do is if you go to vi/tc/hosts, you can open it with sudo. Make sure you update also the EC2 address from Amazon site, and you put it here. And the next thing what you can do is vi/tc/ssh config. We have to update a couple of things here. One is the permit root login. The permit root login, by default it is prohibited, and then we are giving a permit root login to yes, and also the password authentication. If you look out for password authentication, it is initially set to yes and no, and we will be changing it to yes. After changing it, make sure that you restart the SSHD using the service restart command. And other step what you have to also do is restart. You can update the password of the root with just sudo, and with sudo password command you can just make sure you are providing the correct password always. Make sure in the etc hosts you have the right IP. I'll just show you what is there. I have mentioned the private IP address here, so make sure you have it. And now that we have also copied our certificate, the key file onto SSH directory, let's try to do an SSH to that using this command. We are in the home directory now, and .ssh/test, and then provide the complete DNS name. Let's say, and say yes. Right, so now it is copied. It says it is already added now. Now let's log into root. Probably we have to do it with root, so let's try with root, and let's copy the command again from here. Right, so now it has added. Let's try to now that I hope all the configuration is now finished, let's try to format the name node. So that is the first step. We are going to format the name node, and that is cd/opt/apache/hadoop. We are with the Ubuntu, and let's try to use the root. And to perform to format the name node, bin/HDFS name node -format. So it has now formatted. Let's try to start the server. Let me clear sbin/. So you see these are the possible shell scripts available. So we will be starting only the file system, which means only the name nodes and data nodes would be started. We need to provide the passwords because we have made it password specific. So let's try to add that for the first time. Okay, so now that the name node data nodes are started, to make sure that to see if they are really running or not, type jps command, and here you would be seeing the secondary name node, data node, and the name node are already started. Let's also start the resource managers. Type jps again, and you are seeing the resource manager and node manager are also there now. So we have to also perform some changes on the firewall. We have to make sure that the ports of Hadoop's web UI for resource manager and some other ports, they are now blocking on the firewall. We have to make sure that they are now enabled. I have copied the command, so let me try to put one of them. So let's do it step by step. But before that, it says we have to install, so let's install this. All right, now let's okay, add it to the firewall. Let's also add the other ports. So we can now reload. Okay, now on this page you are seeing that you can put in the IP address, the actual Amazon domain name, and with the port 19070 on your local machine, you can see that what is running. So these are the live nodes, what are the dead nodes, and what is the name node information, and where are they available. So we can see, and the data nodes we can see, and we can let's also try to see at 88, and here we see all the applications. At this moment we don't have any, and what is the allocated memory, and this default information we can see. Now make sure you also stop the servers. With this command you can stop the DFS, and you have to also stop the yarn. So this is the end of our presentation. I hope you understood, and let's look at the questions on the quiz. What are the main configurations of Hadoop? You already know by this time. And how do you start and stop yarn, and what is a history server? If you don't know anything, please look at Apache documentation, and keep watching more videos and related videos from Eduonix. Thank you.